Assalamualaikum and hello everyone. Welcome to our presentation titled The Organic Chemistry Behind Perfumes. Today, we will take you on a sense journey to explore how chemistry, especially organic chemistry, plays a major role in creating fragrance we love. This is presented by our group, Danish Hakim, Amma Mustaqim, Abdul Rahman, Abdul Hakim, and Shakir. Let's begin. Perfumes aren't just bottle scents, they are chemistry in action. At the heart of perfume lie molecule and bond waiting to interact with your scents. Meet our team, bringing science and fragrance together. So, what exactly is perfume? At its core, perfume is a mixture of three main ingredients: aromatic compound that given its scent, solvent like ethanol to dilute it, and stabilizer to make it last. Perfumes are used for personal expression, attraction, and even creating identity. It's an invisible part of our personality. The story of perfume goes way back. In ancient Egypt, perfume were made from natural oil and resin like milk and frankincense, used in ritual and even embalming. During the Islamic Golden Age, scientists refined perfume production with distillation, especially rose water. In modern time, chemistry revolutionized perfume with synthetic scents like Chanel No. 5, making them more long-lasting and consistent. Why does organic chemistry matter in perfume? Every ingredient, natural or synthetic, is carbon-based. This molecule, with their specific structure and functional group, determine exactly how a perfume smells. Just one small change in molecular shape can change the scent completely. Aromatic compounds are essential in perfumery. They contain a benzene ring which gives them unique stability. This stability allows them to hold and enhance scents. Different atoms can be added to the ring, giving rise to new complex smell.
Let's look at a specific aromatic compounds. Toluene gives off a sweet, almost like almond, like sand. Phenylethanol is responsible for a fresh floral smell and often used to mimic roses. These molecules are stabilized by resonance, that making them reliable and long-lasting. For function of aromatic compounds, these compounds are not only about scent, they act as a fixative. That means they help anchor the fragrance and make it last longer. Think of them as the base of the perfume pyramid, providing depth and staying power. Next, we move to the ester. Esters are created by combining alcohol and carboxylic acid. They are known for fruity and sweet smells. Perfumes use them in the top notes to the first impression that we get. They are uplifting the fresh and bring out the cheerful energy. Common esters that we will find is ethyl acetate in a fruity perfumes with a base smell, or isoamide acetate that have a banana scent. Next, methyl salicylate that gives off a cool and a minty fragrance. This brings to acetylene, then lightness to the perfume opening. Next is the role of ester. Esters are volatile, meaning they evaporate quickly, making them ideal for the top notes. Their role is to grab your attention and add brightness. They make the perfume feel happy and alive from the first spray.
The next part is terpenes. Terpenes are natural compounds found in plants and essential oils. They are made from isoprene units and are responsible for many fresh, citrusy, and floral scents in perfume. Because of their natural origin, terpenes are especially common in eco-friendly and botanical fragrance. Next is a terpenes example. Some common terpenes used in a perfume include limonene, which is a gift of citrus scent, linalool, which is smell like lavender, and geraniol, which bring the scent of the rose. They are usually used middle notes to recreate heart and harmony in the fragrance. The function of terpene in perfume. Terpene are usually found in the heart or a middle note of a perfume. They form the core character of a fragrance, creating a lasting floral or herbal body after the top notes fade. They also interact with other ingredients to create layered, natural smelling composition. Next is a fixative. Fixatives are heavy, non-volatile molecules that evaporate slowly. Their role is to make the fragrance last longer and to stabilize other more volatile ingredients. Without fixative, your perfume would fade so fast. Next, fixative example. Common fixatives include musk, either natural or synthetic, with a warm, sensual scent. Ambrosite is another one known for its woody, amber-like aroma. These ingredients don't just smell good, they anchor the entire perfume formula.
Function in perfumes. Fixatives play a critical role in perfume. Their main function is to increase the longevity of the fragrance by slowing down the evaporation of more volatile components like esters and terpenes. They also act as scent stabilizer, ensuring the blend stay consistent and harmonious from the first spray to the final lingering note. Without fixatives, a perfume might smell amazing at first, but disappearing within a minute. That long-lasting scent you love hours later, that's the magic of fixative at work. Functional groups in fragrance. The scent of a compound is determined by its functional group. Aldehydes, esters, alcohol, and ketones each contribute different olfactory experiences. Linalool gives a floral scent, citral gives citrusy vibes, muscone brings muskiness, and esters like ethyl acetate bring fruity freshness. Why functional group matter? Even if two molecules have the same atoms, different structure lead to different smell. That's why the functional group is so important. It controls the scent's identity. Chemistry is the invisible artist behind every fragrance. Natural versus synthetic. Perfumes can be made from natural or synthetic ingredients. Natural ones come from plants or animals, but can be expensive and less stable. Synthetic are late-made, more affordable, consistent, and long-lasting. Why synthetic matters? Synthetic aren't just cheaper, they also avoid allergens, support vegan products, and ensure ethical sourcing. Plus, they allow perfumes to design smell that nature can't even make it.
Next is main challenges. But perfume making isn't easy. You have to balance top, middle, and base note, avoid unwanted chemical reaction, and consider how each person's skin might change the scent. Plus, safety is a concern. Some ingredients can trigger allergies or hormone disruption. Real life examples. For example, too much aldehyde in a perfume can irritate the skin. An overdose of synthetic musk may disrupt hormones. That is why testing and formulation matter a lot in the perfume industry. Next is conclusion. Perfume is both
art, and science. Organic chemistry brings each scent to life, shaping how we smell, feel, and even remember. Behind every drop is a molecule with a story to tell. Future of perfume. The future of perfume is exciting. Eco-friendly scents, biotech ingredients, and even DNA-based personal perfumes are becoming reality. One day, your perfume might be made just for you, based on your genetics and mood. Thank you for watching our presentation on the organic chemistry behind perfume. We hope you now see perfume not just as a fragrance, but as a masterpiece of molecular magic.